One more time to look at a problem that would be going over using calculator. An ecologist began studying a certain type of plant species in wetlands area in 2013. In 2015, that's when T is 2, there were 59 plants. In 2021, that's when T is 8, there were 118 plants. The number of plants in this species can be modeled by a function P given by this, where P is the number of plants during year T and T is the number of plants since 2013. It says first, use the given data to write two equations that can be used to find the values for A and B in the expression for P of T. Okay, first thing you have to do is plug in your 2 points. They gave us a point right here. This is a point when T is 2, or X. When our input is 2, our output is 59. Our other data point they gave us is right here. They tell us when the input is 8, our output is 118. How do I write two equations out of that? Remember, P of T is equal to, it says it right here, A times B to the power of T. So how do I write two equations? Hey, stay with me, please. How do I write two equations? What do I do first? On this point, which one's the number of plants? P of T means plants. 59. So 59 would equal, we don't know A, we don't know B, but we do know T. How much time for 59 plants? 2. That's one equation. The second equation, how many plants are there right here? 118 equals A times B to the power of 8 is our time. So on this type of free response question, that first one is the only part you don't need a calculator for. Everything else you do. So part 2 says find the values of A and B. We don't actually have to do any crazy math. You can use your calculator. Let's do that now. So I'm going to plug in my points. I'm going to add a table. I'll type these in. My input's 2. My first input's 2. My first output was 59. My second input was 8. My second output was 118. I'm going to do a zoom fit. Regression. What type of equation is this right here? Is that linear? No. What type is it? Exponential. Go to exponential. There's our equation right there. Oh, man. Okay, there's my equation. It does not ask for the equation, it asks for the values of A and B. How many decimals do you need? 3. So A is approximately 46.828 or 829? 828, and B is approximately 1.112 or 123? 122. I think I said that wrong, but you got it. There they are. That's the second point here. This is the first point right there. Those would be your solutions. Okay, on part B has to do with the A-rock. So on this type of free response, part B will deal with the A-rock. Okay. It says use the data to find the average rate of change in the number of plants from 2 to 8 years. Express your answer as a decimal approximation. Show the computations that leads to your answer. You have to show your work, but here's a way you can get this. We talked about this. I think it was in your class. We talked about this. The way I've thought of how you can do this, first with the calculator, make sure you get it right. Number 1, you make sure you're only using the 2 data points they want. They want a time of 2 and a time of 8. Those are the only 2 we have, so we're good there. Go up to this edit list, and I want you to copy your data. Hit edit list, hit copy, duplicate. Everybody good there? Now secondly, what I'm going to do while I'm on edit is I'm going to hit the black. I want to have a different color. I'm just going to choose red. So I'm going to have a different color. Now, AROC does not look like exponential, ever. AROC never looks like exponential. What does AROC actually look like? Linear. Choose linear. So at this stage, you should have 2 regressions going. Does everybody have 2 regressions going? Okay, the linear, if you remember, your AROC is your slope. Is everybody's slope the same as mine? 9.833. Everybody getting that slope? Okay, I have to show the work, but that right there is going to be my solution. I better get that as a solution or else I did my math wrong. Whoops. If I don't get that as a solution, I did my math wrong. So let's make sure we do our math right. That's the number I'm looking for. So what is the formula for AROC? It's the change of y divided by the change of x. Okay, I'm going to slide this over so you can see. What were my original y values? 118, so it's 118 minus 59 over my 8 minus 2. Now that we can type in the calculator, that shows our work. We should get this value right there. We should get 9.833. That's what we should get. Now I'm going to type it in just to make sure I get this point. I want to make sure I did my work right. Let's just type it in and see if we get the same value. 118 minus 59 divided by 8 minus 2. Yes, I'm getting the same value. That's good news. So there's our first point. And I'm going to go ahead and put over here for the sake of notes that this was a linear regression. Because AROC is a linear regression. Okay, now it says, use the average rate of change found in I to estimate the number of plants for t equals 10 years. Show the work that leads to your answer. Well, we know what the equation is. This is the equation right there. Now, if that's my AROC, how to show my work, how could I show my work to get my answer? Where would I plug this 10 in? Is that an X or a Y? The X. So really, the work I would need to show is Y would equal 9.833, I'm going to round here, times 10 plus 39.333. I'm rounding off. Now over here, you don't actually have to type all that in. You could just simply type in X equals 10. Now, which intersection am I looking at? The red or the blue, the black? The red. Why the red one? Because this is the AROC, the other one is the exponential model. So that's my answer right there. Is everybody cool with what I'm doing so far? Whoops, 137.667. So can you have that many plants? Can you have a decimal of plants? So I would actually write the answer here of approximately 138 plants for t equals 10 years. Okay, so I would actually write that for my answer, just because you can't have a decimal of a plant. So that should make sense. Okay, it says the average rate of change found in I can be used to estimate the number of plants for t when t is greater than 10 years. Are these estimates found using the average rate of change less than or greater than the number of plants predicted by the model P for year t for t greater than 10 years? Okay, so I want you to explain it to me from this. Here's t equals 10 years. It said, hey, if we looked for t being greater than 10 years, which side of the graph we looked on? Left, right, top, or bottom? If t is greater than 10 years, we're looking on the right side. Which one's greater? The exponential model or the AROC linear model? The exponential is greater. So I'm going to write my answers. Are these estimates used found the average rate of change? Okay, that's the average rate of change first. So how is this the average rate of change compared to the exponential? Is the average rate of change less than or greater than the exponential? Less than. So I would write about this one because that's what it said. Are these estimates found using the average rate of change? I want to say, why did it do that? Sorry, let me delete this, delete that. Okay, here we go. The estimates found using the average rate of change. I'm just copying this right here. Did you say it's less than or greater than the exponential model? Is less than the exponential, or excuse me, less than what it said, the number of plants predicted by the model P during year T for T greater than 10 years. Now it says explain your reasoning. The reasoning you always say is about the concavity. Is this less than because this graph, is this less than because the model is concave up or concave down? What is going on with the black model here? Okay, it's less than. So I'll just add that in here. Since the model P is concave up. For, I don't know if you'd have to say this, but I'll just do it again. For T greater than 10 years. Is that it?